Hi, this is Wes Simpson, contributing editor for TV Technology Magazine and founder of Learn IP Video. I'm here today with Geeter Kyrazis, who is the business lead of Switch.io, a company that is providing a set of virtual networking services that have the promise of revolutionizing cloud production workflows and all types of media. Geeter, can you give us a 30-second summary of what Switch is offering to the television production and broadcast industry?
Sure, Wes. Thank you for having us. We're happy to be here this morning. Switch is offering as you say, a variety of different network capabilities, or you describe them as services. Really what we're doing is providing software-based solutions that are analogous to hardware-based network architecture, including software-based switches and NICs. And what those collectively do is implement a network on top of cloud or broadcast networks, on-prem networks, that execute and implement features that aren't possible on those networks normally. Things like multicast, SMPTE 2022-7, PTP transport, and other things that are essential to broadcast production infrastructure, but aren't usually available on the networks that we operate on.
So what are the main markets that Switch is serving today?
There are lots of markets that require especially cloud networking capabilities that aren't natively provided by the clouds. Those markets include broadcast, which is our largest and kind of most focused market. But we started in financial services. Our parent company is a financial services firm. And much like broadcast, financial services workloads require high performance networking and features that aren't provided natively by the clouds. We also have a lot of interest and activity in government networks, in IoT, video camera surveillance systems, and audio distribution. So there's lots of different markets that can't take the cloud networks as they come and require additional features to be able to make themselves work in the cloud the same way they do in their on-prem instantiations.
Well, that's interesting. So one of the things that I know about your company is that you provide multicasting services, which really aren't feasible in the, or I should say multicast capabilities. Those really aren't feasible in a current basic plain vanilla cloud implementation. Why is that important, and what is it that you do differently than everybody else?
Well, multicast is a really useful feature. It's been around for 30 years. And for a lot of different networks and vertical markets, it's essential. The clouds typically don't implement multicast on their core networks for a lot of reasons, having to do with security and reliability and scale. So when a network team that's trying to build out, a global infrastructure looks at the problems of multicast versus the benefit, they say it's not worth it. So AWS does have a multicast instance in their transit gateway solution that is configured for certain, I would call them non-scalable workflows, but it's still there. But in general, multicast as a method of replicating and distributing packets is required for many different workloads. It's obviously a feat or a specification-based requirement for SMPTE 2110, as well as being essential to financial services workloads. So being able to implement multicast in the cloud at scale and with the exact same features and lack of modification on the application's part that they would have if they were to deploy a Cisco or Juniper switch in their on-prem network and turn multicast on is our objective. That's what we're trying to do, is to create a software version of a switch that has the same features or very similar features to a hardware switch and just allows that traffic to just magically flow across the cloud, even though the cloud doesn't natively allow that to happen.
Yeah, you're absolutely right. I mean, most of the on-the-ground workflows for SMPTE 2110 are very heavily invested in multicasting. And it sounds like you guys have a solution that will scale. What does that really mean? I mean, what are the limits? Are there anything that you need to say about what can and cannot be multicast?
No, not really. And the reason is because we aren't a service. We're not providing network services. We are a software application that gets deployed in the customer's tenant. So much like they would deploy a physical switch in their broadcast network, they deploy a software switch into their virtual network. And they can deploy any number of them. So to the extent that you can scale a physical network by buying a lot of switches, you can scale a cloud virtual network by buying a lot of our cloud switches. So if you have a load that requires that you support tens, hundreds, or of thousands or millions of users, you could do that by creating a mesh of our cloud switches and having all of those packets get distributed to as many endpoints as you wanted. In terms of which multicast workloads we support and which ones we don't, that again really isn't a limitation. I mean, we are compliant with the IGMP standard for how you create a multicast network and leave or join it. So if you're able to do multicast in an on-prem network, you can do it in the cloud using the same exact technology. You don't have to change your application at all. So obviously there's always scaling factors. I mean, if you don't have the footprint, if you don't have a data center near your customers, you're going to have latency issues or other connectivity issues. But in general, as long as you can get, a network connected to somebody, you can get multicast to them.
So you mentioned scalability. Is that dynamic scalability? In other words, if I need to put together a workflow for, let's say, a big event and then tear it down when I'm done, is that feasible using the product that you provide?
It's a fundamental use case. It's the whole reason why the cloud is so popular, obviously. You have elastic scaling. So if you had an event where you needed to do a remote production and you needed to be able to, have a bunch of editing systems, playout servers, archiving systems, all the infrastructure that you would normally need to be able to be spun up into virtual machines, execute the event for 3 or 4 hours, and then turn it all off. That's exactly what we do. That's the benefit that you get. So yes.
That's great. That's great. So one of the other things that I thought was really interesting about your offering is the ability to provide PTP in the cloud. How does that work, and why are people so excited about that?
Well, obviously, PTP is a very essential requirement for many different time-dependent workloads in broadcast and other places. It isn't available in the clouds today. Some would argue that it is a natural first-party solution that the cloud should provide, but they don't. And there's lots of implications with having timing be accurate across a global, non-deterministic network. So in order to make that work, it helps to have a switch. One sort of underlying but not obvious reality is if you want to push PTP packets around and be able to have them be standards compliant and normal the way people normally use PTP, you have to have a network that can distribute them, and typically a multicast network. So the fact that we have this switch, which has a lot of overhead to add new features to it, and it implements a multicast network, we have a very convenient place to put PTP distribution in the cloud. Now, there are various players that have, let's just call them clock synchronization algorithms of various types that attempt to minimize the timing errors between different virtual machine workloads. And those are great, but they shouldn't be implemented as a service or they won't scale. And they also should survive the cloud to ground transition. So what we do is we have a third party that we work with called TimeBeat, who has a clock synchronization methodology that we've implemented in the cloud switch. What that does is make certain that across the different virtual networks, and that can be across clouds even, we have the best possible time synchronization accuracy. And we're getting, in many cases on certain clouds, single-digit microsecond synchronization between virtual machines. And even across fairly difficult networks, low double-digit microsecond synchronization. So quite sufficient for the workloads we're talking about. But more than that, we can actually transport from a grandmaster clock in an off-cloud network those PTP packets into the cloud and synchronize the entire system as if it was a normal PTP synchronized broadcast network.
No, that's great. Yeah, single microsecond is really, really important for some of the audio workflows in the media industry. So that's really good to hear. Regarding your recently announced agreement with AWS, what new capability does that open up for your customers?
Well, obviously, AWS is currently the market leader in the cloud for broadcast workflows. Everyone has to run on AWS to some extent. So all of the features that we normally talk about, multicast, again, is provided as a first-party solution by AWS's Transit Gateway. But even AWS would admit that there are lots of things that CloudSwitch can do that Transit Gateway can't. And so we will be adding to the multicast capabilities on AWS. We'll also be adding the ability to move PTP traffic into AWS. We also have a native 2022-7 redundant network path capability that's built into our switch and NIC architecture. So the applications don't have to know about it at all to do multi-path packet routing across AWS. And also we could do that across AWS and other clouds. So if you want to build a multi-path network You could build it across, GCP and AWS or AWS and Azure or whatever. In addition, we have many other features that are kind of come along for the ride. We have something that's really important to broadcast workflows that no one really knows about yet, which we call protocol fan-out. And what that means is we can essentially take a non-multicast signal, a unicast signal, and we can distribute it as multicast to multicast-dependent endpoints. We can do the same thing with SRT. And we can do the same thing with multicast to unicast or SRT. So it essentially become a protocol conversion gateway, if you will, in the middle of the network. What that does is allow the building of a best of breed architecture in the cloud in a way that you can't do without it. You have an application from an Evertz or an Imagine or a Grass or somebody like that has some protocol dependency. It can only consume or produce unicast, or can only do the same thing for SRT. If you want to integrate those solutions into a broadcast network, you have to have a way to convert those protocols. And if you want to do it in the applications themselves, you get a big spider web of different integration points, and it becomes very difficult to manage. With a switch in the middle of it, first of all, you can switch SRT, right? So you can take an SRT signal in, which is typically a point-to-point protocol, and fan it out. But at the same time, you can allow all these different applications that don't normally play well together be part of a switch network where they can freely join and leave and build whatever kind of configuration or architecture you desire.
So are there any plans to upgrade the system to support RIST as well?
Yes. Yeah, there will be other protocols we'll be supporting over time. RIST is one. NDI is another potential. And then there are other kind of lower level protocols like TCP and QUIC that we will be supporting as well, in the sense that multicast is kind of both a protocol and a concept, right? Mm-hmm. It's the concept of fanning out packets. It's also a protocol standard. So if you can have the ability to fan out non-multicast protocols in the same way you do multicast, you get the benefit of that sort of subscriber-based distribution without having to be multicast dependent. And to do that, we supply an IGMP-like interface that allows you to very simply leave or join a group, much like it would be a multicast group, but it wouldn't be multicast. So yes, RIST and other protocols are on the roadmap, and the notion that this protocol fan-out is useful, and when we currently support 3 protocols, will become more useful as we add more.
So Geeter, many of our listeners have probably heard of a company called The Switch that was recently announced a merger with Tata Communications. Does your company have anything to do with The Switch?
We do not. We share a few letters of our name, and that's it. Okay. We call ourselves Switch.io for a reason, and that's kind of by design. The Switch is a network provider. They provide the infrastructure to transport packets. We do not. We're a software solutions provider, and you run our software on your own network. So the Switch could theoretically be a customer of ours.
Very good. Very good. How can folks learn more about Switch.io and some of your products?
Well, we'd love to see you at NAB. If you're at NAB, we'll be exhibiting in the Microsoft booth as part of their Microsoft Live workflow. We'll be also integrated with Tag Video Systems, Evertz, and others. So we'll be and Cinefilm. So we'll be in their booths as well. And we'd love to get in touch with you and schedule meetings if you're interested to learn more. But the most consolidated place is at our website, which is switch.io. That's swxtch.io. You can find a lot of media-specific pages there. We also have a documentation system that gives comprehensive insight into our software solution, deploying it, using it, and that sort of thing at a website, it's available as a link on our primary website, but the link is docs.swxtch.io. And you self-register there. You have to give a name and an email address, but then you immediately get access to the Docs website.
I get to do a technical deep dive. That sounds like
absolutely
fun.
Yeah. Learn more than you ever cared to.
Yeah. Okay. I've been talking with Geeter Kyrazis of Switch.io. My name's Wes Simpson. I'm founder of Learn IP Video and also the contributing editor for TV Technology Magazine. Thank you very much for joining us today, and we'll see you all at NAB.
It's our pleasure, Wes. Thank you so much. Appreciate it.
Thank you.